Welcome, architects and developers. Today we are diving into one of the most powerful paradigms in agentic AI, the ReAct methodology. We are going to explore how combining reasoning and acting transforms static models into dynamic problem solvers. Let's get started. To kick things off, we need to define what the ReAct methodology actually is. Historically, large language models were seen as passive brains. You asked a question, and they relied entirely on their internal, pre-trained weights to give you an answer. ReAct fundamentally changes this paradigm. It stands for Reason plus Act. It is a framework that elegantly interleaves internal reasoning traces with external, task-specific actions. This means the model doesn't just think, it reaches out into the real world, executes tools, gathers fresh data, and then reasons about that new data. By decoupling the reasoning from the acting, we create a continuous feedback loop. This is the exact mechanism that promotes an LLM from a simple chatbot into a highly capable, autonomous AI agent. Looking at this flowchart, you can visualize the paradigm shift. A user request comes into the ReAct agent. The agent first enters the internal thought phase, where it reasons about the problem. But instead of guessing the final answer, it decides on an external action to take, like searching a database or calling an API. The environment then returns an observation, which flows right back into the agent. This continuous loop is the heartbeat of the ReAct methodology. Let's break down the core mechanics of ReAct. The entire framework revolves around a three-step iterative cycle: thought, action, and observation. First is the thought. Here, the LLM acts as an internal monologue. It analyzes the user's goal and explicitly states what it needs to do next. For example, I need to find the current stock price. Second is the action. Based on its thought, the LLM outputs a command to use a specific tool, like a financial API, passing the correct stock ticker. Third is the observation. The application executes the tool and injects the raw result, say, $150 per share, back into the LLM's context window. The agent then starts a new thought based on this observation. This loop repeats as many times as necessary until the agent is confident it can synthesize a final, accurate answer. This sequence diagram beautifully illustrates the chronological flow of a single ReAct cycle. The agent starts with a thought, realizing it lacks weather data. It sends an action to the external tools. The environment processes this and returns an observation, 22 degrees and sunny. With this new, factual grounding, the agent formulates a second thought, concluding it has enough data to satisfy the user, and finally outputs the final answer. Notice how the reasoning strictly drives the tool execution. Why do we need ReAct when we already have techniques like chain of thought? While chain of thought is fantastic for logical breakdown, it has a fatal flaw: it is completely isolated from the real world. If a standard COT model doesn't know a fact, it will still try to reason through the problem, ultimately hallucinating a highly convincing, yet entirely fabricated answer. ReAct solves this by anchoring the reasoning process to external reality. Because the model can execute a search or query a database, it relies on factual observations rather than latent, possibly outdated knowledge. Empirical studies show that ReAct drastically reduces hallucination rates compared to pure COT. Furthermore, it provides incredible adaptability. If an API is down or a search yields no results, the agent observes the failure and can generate a new thought to try a different tool or search phrasing. Compare the two strategies on this diagram. On the top path, pure chain of thought relies exclusively on internal weights, leading straight to a high hallucination risk, highlighted in red. On the bottom path, the ReAct framework maintains a bidirectional relationship with external APIs and databases. By fetching live data before drawing conclusions, the ReAct path consistently results in a highly accurate, grounded answer, highlighted in green. How do we actually force an LLM to behave this way? It comes down to structured prompt engineering. We instruct the model that it must operate using specific textual markers. It is told to output thought, followed by its reasoning, then action, followed by the tool name, and action input for the parameters. The surrounding orchestration code like LangChain acts as a parser. As the LLM streams its response, the framework watches for the word action. As soon as it sees it, the framework pauses the LLM, parses the requested tool, executes it in Python, and then appends the word observation, along with the result, back into the prompt. To make this reliable, we rely heavily on in-context learning. By providing the LLM with a few perfect examples of thought-action-observation cycles within the system prompt, the model easily learns the required cadence. This flowchart demystifies the orchestration layer. The system prompt initializes the LLM generation. As the text streams, our parser constantly checks, did the model output the word action? If no, it keeps generating. If yes, it immediately halts the LLM. It then executes the corresponding Python tool, takes the real-world result, appends it to the prompt under the heading observation, and restarts the LLM generation loop. It's a perfect dance between text generation and code execution. While building a ReAct parser from scratch is a great learning exercise, enterprise developers use frameworks like LangGraph to handle the heavy lifting. LangGraph provides a pre-built function called Create React Agent. It is elegantly simple. You pass it your initialized LLM, a list of Python tools you've defined like a web searcher or a calculator, and your system prompt. Under the hood, LangGraph compiles a robust state graph. It creates a node that invokes the LLM and a secondary node that handles tool execution. It automatically wires up the conditional edges to loop back and forth until the task is complete. When you execute this agent, you can use the streaming API. By setting stream mode equals values, your application can surface the agent's internal thoughts and tool calls to the user interface in real time, creating a highly transparent and engaging user experience. This diagram shows the modern developer experience. You take your standard chat model and your list of tools and feed them into the Create React Agent constructor. Out comes a compiled state graph. You don't have to write the routing logic. The framework automatically sets up the LLM node and the tools node, connected by a conditional loop that seamlessly manages the back-and-forth React state. Let's apply this to a highly critical, real-time use case, financial compliance auditing. Imagine an agent tasked with approving a high-value loan. In iteration 1, the agent's thought is, I need to check the applicant's credit score. It executes the Get Credit Score tool and observes the result is 720. Crucially, the agent doesn't guess the approval criteria. In iteration 2, its thought is, I need to know the current corporate policy for high-value loans. It triggers a RAG retrieval tool, observing that the policy mandates a minimum score of 740. Finally, in iteration 3, the agent synthesizes the facts. Thought, the applicant's score of 720 is below the required 740. It generates the final, auditable response denying the loan. The ReAct methodology ensures the decision is 100% grounded in retrieved enterprise data, avoiding costly hallucinations while providing a clear audit trail of its reasoning. Follow the trace of our financial agent. The task enters at the top. The agent pulls the score, resulting in the observation of 720. It then proactively searches the policy, observing the 740 threshold. The cognitive synthesis happens right before the end. 720 is less than 740. This step-by-step external validation guarantees the final answer of denied is both accurate and completely transparent to human auditors. To wrap up, ReAct is not a static concept, it is evolving rapidly. We are now seeing methodologies like ReAct, where smaller, cheaper models are fine-tuned explicitly on successful React trajectories. This allows highly efficient models to perform enterprise-grade reasoning. We're also seeing extensions like reflection, which adds a self-critique phase to the loop, allowing the agent to learn from its immediate failures. Understanding ReAct is the absolute baseline for transitioning from building simple chatbots to architecting production-ready, multi-agent systems. Thank you for joining this masterclass. I invite you all to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Keep building and stay curious. Our final diagram shows the roadmap for agentic growth. From basic ReAct, you can branch out into adding reflection for self-correction or fine-tuning trajectories for efficiency. Both pathways converge at the deployment of robust enterprise AI systems. And to accelerate that journey, follow the final arrow straight to quicktechie.com to master these skills.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.